So how can clustering help a prospective applicant? I've told you that if you take GMAT score, if you apply to a college, then if you have a bunch of other colleges which are similar to the college that you're applying, it makes your life easier. Second is from the dean of the college perspective. They also want to compete with the colleges which are similar in nature. For that reason also it exists. And now, what characterizes each cluster? Can you give a name to each cluster? Does this give us any insight? That is the objective that we are left with. So if you go with a single linkage, you have all these clusters which are formed, right? And when you go with a single linkage, and if you analyze this data of all these universities, say you have 12 here and 22, here we have 12 and 22. Probably, these two are connected to each other. So these two are very close to each other. Right? So, but you cannot really form the similarity. We really don't know whether these two are similar or not. And you have 9 and 25. You have a 9 which is Harvard and 25 Yale. Probably these two are together, right? Yale and Harvard are tier 1 colleges. So those two are forming a cluster. But as opposed to your single linkage, when you use your R code and run complete linkage, this might make more sense. Let us see. You have a 9 and 25 here. So Harvard and Yale University are clustered together. And also 6 and 7 are clustered together. Dartmouth and where do we have 7? Duke. And 17 is also clustered with this cluster. That means you have Stanford University. And 15 is Princeton. All right. 11 is MIT, which is also very good college. And then you have 10 and 2. What is 10 and 2? One is Caltech and 10 is John Hopkins. So I get a sense that this cluster here is your tier 1 colleges. And probably Brown, Georgetown, Columbia, Cornell, and Northwestern, 22nd University of Pennsylvania. Probably all these are your maybe tier 2 or tier 3 colleges. So you get a sense on what colleges are grouping together. But you need to spend some time on this, right? It's not that easy, right? Less the distance, more is the similarity. So there is more similarity between 12 and 22 as opposed to 5 and this cluster, right? That's the distance. So the more the distance, less is the similarity. And the success of clustering exercise is determined, right, using the labeling exercise. If you can successfully label a cluster, a group of entries, that determines the success of clustering exercise altogether. And if you look at this dendrogram, yep. So if you cut it at this location, you'll get 2 clusters. If you get hold of this with your hand, entire thing is one cluster. And if you get hold of this with your hand, this entire thing is a cluster. So now you have 2 clusters. But there will be a lot of dissimilarity between these 2 clusters because the distance is more. If you see here, it is distance. So the distance is very high basically. And if you look at, or if you cut at this point, then if you hold this entire thing is a cluster, one cluster. If you hold this entire thing is another cluster. And if you hold here using that small tip there, this one is one cluster. So you have 3 clusters in total, right? But as and now you come down here, distance reduces. Means what? Similarity will increase. Similarity between the groups. But again, it's a business call that you, sorry, it is a business call that you need to take on how many clusters really make sense. Hence, without domain experience, you cannot do anything. So my sincere suggestion to people who are listening to this tutorial is get aligned to one of the industries, financial services, insurance, or life sciences, healthcare, or energy and resources, or airlines, or get aligned to one of the industry and start accruing as much industry knowledge as possible. Without that, you would be outdated, outsmarted by the other folks. All right. So in the next tutorial, I will explain this using the R code.